Welcome to the radio room. We got a BTECH UV-25x4 times 4, however you want to look at it. Just a tiny little radio. Supposed to be, I believe, a 25 watt output radio, and that's a pretty small radio. So there's my hand. I can pick the whole thing up, no problem. Came in and says receive works fine, but it does not transmit. And from what I've seen, that appears to be a common problem on these, or at least maybe on the older ones. And it typically is the final transistor ends up burning out. From what I understand, a little bit of research I've done on these early models, especially when they were Bofangs, I'm guessing, had a very undersized final transistor in them for what they were trying to get out of them. And I don't know if that's the case on this one, but apparently it receives and it doesn't transmit. So let's go ahead and hook it up some power and turn it on, and let's see if we can see what's going on here. Get some power hooked up over here. Using Anderson power poles. Okay. Let's see if we can figure out how to turn the thing on. Okay, well, it turns on. Got several memories in it. Let's see, let's go to VFO. And I'm kind of curious. It's making a clicking noise. I do find very interesting. I have never used this radio before, so I'm definitely going to be figuring it out, so to speak. So we're figuring this radio out a little bit as we go here. Trying to see if maybe just got a simplex frequency in here. Okay, well, let's Maybe I ought to read the manual first. Okay, that's the menu. I'm trying to figure out how to. Well, there's a simplex frequency. I was just trying to find something to make sure this thing's receiving okay. So I'm going to hook up a little tiny SA as the signal generator, and we'll make sure that it's receiving. It's 146.52. Put some wide FM on it. And let's just call it a 800 hertz tone. Seems to be, we should be getting some more something out of there. I got a fairly strong signal in there. It's either that or I am just not running this thing correctly. Well, it's like it opened the squelch for a moment. Maybe we got a tone squelch on or something. Let's go into the menu. Okay, so we do have it receiving, although to me it doesn't necessarily seem real sensitive. Turn the there we go. So it's receiving fine. I was on wide versus narrow FM. That's all that was causing that problem. So let me turn this down even further. That's a full scale signal there. And it's still mostly a full scale at the lowest the tiny SAO goes, so that's still a good signal for that signal level. So we know it is receiving. Now we need to see if it's transmitting. And this is the problem I was told that it had, is that it did not have transmit, which, like I said, is probably, I'm thinking possibly the final amplifier is out on it. It is going into transmit, but I am getting nothing on the, let me get this up here. Maybe you guys can kind of see it as well. Just kind of set it there, maybe, like so. I'll move y'all up just a little bit. And from what it's saying, does show it's on high power. And it's got nothing coming out. Sorry about my hand getting in the way. Okay, and now we're on 446. Doesn't look like we have any power out there either. Let me, okay, that is transmit low, so let's get that up on high. Absolutely nothing coming out. Very interesting. So I'm thinking that it's not. We don't have anything coming out. I mean, it's not even moving the needle. And on high power, this thing ought to be pegging that needle. So let's take a look on the inside of it. And turn it down or turn it off. Might actually have to read up on this thing just a little bit to figure out the operation on it just a little bit, but the owner did say it was not transmitting, so we're going to go off of that. So I'm pretty sure that's accurate. Let me go ahead and change the view here. See if I can get some little better light on it. And we'll see what's inside one of these things. Okay, well, there's not a whole lot in there. Well, I'm going to take a really serious guess and say that the final transistor is probably underneath here. I mean, I don't have a schematic for this. I didn't even look for one. Looks like this board was made in 2016. But you know, if you're getting into a radio like this and you're trying to figure out which one's the final, there's a couple of clues you can go off of. For one, of course, everything in this radio is close to the antenna connector, but the final is usually going to be relatively close to the antenna connector. Two, the fan is blowing right here, and it's got this large, I'm guessing that's probably copper right there, or brass, so you know that's heavily heat sinked. So that's a good indication that's probably the final amplifier. I'm going to take this heatsink off the top of it and see if we can see what we're dealing with as far as a final transistor. Ooh, that's just a little guy. Wow. So it's Well, 25 watts out on that little bitty guy right there. So, right there's the final transistor. That's just a tiny little thing. I was almost expecting something a bit bigger than that. AM9, or no, A9M15. Wow. I'll have to look up a data sheet on that. See if I can figure out what's going on with that. I'm going to hook this up for just a moment again. Well, that's just interesting. That connects there. Right. I'm going to hook that up. I'm going to hook this back up to the dummy load. One thing I didn't notice before, let me, there's something in here that's don't need to be rattling around. Standoff for the heat sink. Yes, I want to see if that fan comes on when you transmit. Yeah, I'm guessing that thing's just waiting for it to get warmed up. Because I do not see the fan coming on. .8 volt fan. I'm kind of wondering if the fan has maybe gone out. And therefore is things got too hot that way. Let's see if it's got any voltage to it right now. No voltage right there. Kind of assuming this is kind of assuming this the chassis on this thing's grounded. We're going to find out real quick here. Yeah, it is. I was just going to ground there and sticking it in the back of that power pole. I do get 13.8 volts. So is it supposed to come on, or is the fan maybe out? Let's see what happens when I transmit. Okay, I'm guessing that's probably it's probably thermostatically controlled, or whatever's driving the fan isn't working, because even when I transmit, it doesn't necessarily put voltage to the fan. So I'm going to have to look at the data sheet on that. I'm trying to think of anything that I can see or that I can do to check to see if it is getting. It'd be really nice if I had a schematic on this. I would guess that the gate is probably where it's being fed the signal from the driver, if there is a driver. There's got to be a driver. To see if there's a driver signal, should be coming into the gate. Might be able to see that on the O-scope to see if it's even trying to transmit. But let me pause for a few moments now. I want to look at the data sheet on... not that this thing's going to do anything to me, but I don't want to stick my fingers in here. It's not going to hurt me, but... on the final there, let me look at the data sheet on that. And let me see if maybe I can find a schematic on this thing. I kind of think I'm not going to. It just seems like some of these BTECH, Bofang, there's not a lot of support documentation that I've ever found on this. I might be surprised. But let me pause, let me take a look at that and see if there's anything coming out of this thing. You know, even if, unless that's just totally shot. I mean, like totally disintegrated, and there's no path in there. We might be able to get checked to see if there's a signal coming into it off the driver, which I'm not entirely sure where that's at on this, or if they're just sending RF straight to it, isolated RF straight to it. We'll find out, or try to find out. Wow, that just... It's an interesting way to heat sink it. I mean, that looks like pretty much all they're doing there, and I'm guessing maybe on the bottom side of that board there's something, but this might be fun. Trying to see exactly how I'd get this thing out of here to replace it. It looks like maybe the source of the FET, I'm guessing it's probably a FET, is maybe like the back, on the back side of it, and it's actually soldered and set down on the source. So maybe we got a gate and drain, or drain and gate on each side of it. I'm not sure if you guys can see that, but it looks like there's a contact here that's running over this way, and then almost like these two little ones on each side. See if I can get this so y'all can see it. Like these two little tabs on each side, maybe, or the source. And what I'm saying is, why I'm thinking that might be source, is a lot of times source is to ground, and maybe underneath this board that's actually sitting down on something that's grounded. Yeah, I'm only getting like 0.4 volts or 0.4 ohms, which is what my meter's sitting at anyhow. That side's that seemed odd. Okay, so that might be, let's see, let me go back to this side now. Okay, so I don't know if I can really test this in circuit, if it is a FET. If that's the source, if that's the gate, kind of acts like it. I mean, I get 150 ohms or something just for an instant, which could be the capacitance charging. And then I get 2.1 ohms. So I'm going to try this both ways here. 2.1 ohms. That's the gate, and that's the drain. Let's make sure this thing's unplugged from power. Well, I got the power supply off. Which that might be. Oh, it doesn't change. I mean, of course, this might not do this. This might not be very well to test in circuit anyhow. I'm trying to see if I can turn it off. Okay, I think this might be the gate. Because I touch that there, come over here, and I get a momentary conduction through there. Okay, we'll have to pull a data sheet on it, see what it is. Let me do that. See if I can find a schematic on this thing or something. I have a feeling that's bad, but I need a way to kind of check it. And I need to figure out exactly how it's in there, because that's going to be fun to get out of there. Unless I can figure out exactly how they got it in there. There's no real solder to see. Unless it's right underneath that. That might be a very, very gentle hot air removal. Let me see if I can figure out how this thing's put together. I'm not 100% familiar with that package right there. So let me pause and I'll take a look at this stuff and see if I can get back and maybe we continue figuring this out. Okay, we're back. I got a chance to look at a data sheet for this particular final. Let me go ahead and go to it. Here's the data sheet for that. Now this number is a pretty long number here. I mentioned that the number that I seen on there was A9M16. And it took a little bit of research around, but this number right here, AFT09MS015NT1, it's the same chip. It's the same MOSFET, N-channel MOSFET. It's 136 to 941 megahertz. You can see right here that this is the part that I find interesting, and this is kind of what I'd seen in some of the other research that I'd done before I'd popped the radio open. Just on some forums and stuff. It took a little bit to find this number, in fact. As you can see there, it's a 16 watt MOSFET. And this is supposed to be a 20 or 25 watt radio. Wow. Okay. Seems like they're pushing that a little bit. Of course, from what I understand, in the early runs, they only had a 6-watt one in there. I'm not really sure how that was going. This is just what I've read on forums. So, basically, yeah, this thing gets toasty on high power. It's going to get toasty because it's actually trying to put more power out than it's supposed to. I mean, you can see, 15 watts at 2 meters, 16 basically on 70 centimeters. And of course, the radio's not even playing here, but 15 watts out there. Yeah, that's I think that's pushing things a little bit. But one of the main things I want to see, and this did confirm what I was thinking, the right here, and then there's a little tab on the other side, is the source. The drain, it does have a tiny little, I guess you could say 45 of the case right here that shows you the gate side and then the drain side. So that would, this right here would be right here probably. This appears to be looking down on it. And we're going to confirm which one is which real quick before we test to see if this is dead or not. I think we can test it not directly but indirectly while it's in the radio. Just seeing how it's playing, so to speak. And we should be able to see which pin's which and if it's doing anything and if we have any signal going to it. So let's go ahead and get back to the radio here. Whoops. Let me go back over here. So as this one's sitting, I can get this so y'all can see it as well. I don't know if you guys are going to be able to tell where the 45 is. See how good my camera is. I don't think y'all can quite tell that in there. But this corner right here does have that little 45. It's very, very small. So if that's the case, then over here, get this back up here where you guys can see. This right here should be the drain. This over here along this side should be the gate. And then of course the this little tab here and that little tab there are connected to the source. So there's basically 3 strips on the PCB. It's for gate, source, and drain. So most of the time when a MOSFET is, or most of the time I've seen, I'm not going to say this is every case, most of the time when a MOSFET is used as a RF power amplifier, just simply put, on the drain you should have your supply voltage. In this case, this is a 12. It says it's 12.5 volts, so this is probably just the same power is coming in here. So we should have about 13.8 volts or whatever the power supply is running at. We're at 13.5, 13.8 volts here. Should be on that pretty much all the time. This is going to have the gate. So this is where the signal is going to come in from the pre-driver or driver, whatever you want to call it. And of course, source should go straight to ground. So we're going to double check this to make sure this is the drain. And we'll check and see if there's any signal coming in on that. So let me go ahead and go over to the oscilloscope and we'll see if we can figure all this out. Let me see if I can do it actually and do an inset on this one. There we go. So up in the right hand corner there you do have the oscilloscope, and hopefully y'all will be able to read that. Let me set it up just real quick, because what we're going to do first is we're going to check to make sure that that is the drain, and it should have voltage on it. One key thing on that is, for one, we're going to check to see if it's got voltage on there for 2 reasons. One, hopefully It does, and that's going to tell us that that's the drain. And it's also going to tell us if there's no voltage there, we have bigger problems. If none of these pins have voltage on them, that means we have a problem, and it wouldn't be that. It would be whatever's supplying it. Unless that's directly shorted, but I would assume that I wouldn't be doing this if that was directly shorted. If it was directly shorted between the drain and the source, it would be pretty toasty right now. I don't have the radio on, but let me go ahead and turn it on. If it was shorted, it would already be hot and probably be smoking. And if even then, it'd probably be blowing the fuse in the power supply, or the power supply would be very angry at me and probably be burning up the board at this point. So let me go ahead and get things kind of set up here. I'm going to use this as a DVM, a digital voltmeter, real quick. So we do have our voltage right there. Hopefully y'all can read that. Let me check a little bit on the camera, make sure it's not washing out too much. Okay, it looks like y'all can see that. I want to turn a little light off here. Maybe it'll make it easier to see. Hopefully y'all can see that. Okay, so let me think here. I might have to. Let me do one other thing here. Let me set this up a little bit differently. I just want to do just DC. Just going to use it as a voltmeter. Okay, so I'm going to go to what I'm suspecting is the drain, which is right here. And that is a very interesting voltage we have there. Well, let me try this side. Okay, let me make sure I got things set up here right. Oh, I probably need to change my coupling. This might make a difference. Okay, so yeah, 13.9 volts DC, and I'm on that pin over there, this one right here. The one I was suspecting to be the drain, so that does have 13.9 volts DC on it. The other side doesn't have really anything voltage to, that's just what it's reading off of. Pretty much nothing. Little voltage difference between the chassis of the oscilloscope and the radio power supply, and then source has nothing as well. So that is our drain. It does have voltage on it, which is something we want to see. That means there is voltage being fed to the MOSFET. This would also be the output side in most cases when a MOSFET is used as an amplifier. This would be the output side of the MOSFET. So the source goes to ground generally. There may be a resistor in the way, but I don't think there is. I think that's pretty much straight to ground. The gate, which is controlling the MOSFET, is where the signal's coming in. So if the MOSFET's used as a final amplifier, it's probably coming from a driver or pre-driver. Driver, and then it. This might just have a driver, and then this one. And then this is the supply voltage and the output side of it. Okay, so what we need to do is we want to find out if this radio is even putting anything out or trying to put anything out, and the final is just the last step that's blocking everything. The easiest way to do that is to find out if there's a signal coming in on the gate. So that's going to be this side over here. So let me get the oscilloscope set up a little bit differently. We are going to oops, nope, I need to back out of that. We are going to be going, obviously, anything we put into it is going to be AC. I mean, it's RF, it's AC. So I need to have my oscilloscope set on AC coupling. Okay, so what we're going to do is we're going to go over to the gate while we're transmitting. I'm on the 146.52. I have 150 megahertz scope, so I'm pushing the accuracy of this oscilloscope. In fact, it's probably already going to be attenuated some because I'm so close to the top end of it. So I'm going to just go into ground on the chassis, and hopefully I'm on ground. That there is some paint on the outside here, but that should be pretty close to being on the ground. So let's see here. Let's make this thing a bit more sensitive. So I'm going down to 200 millivolts per division. I'm on 10 nanoseconds right now, so that should be pretty close to see a waveform if we have one. So I'm going to go ahead and stick my probe on the gate. That just looks like noise right there. And then I'm going to key the radio, and we're on high power right now. And there is a signal there. Okay, so one thing I am going to do is I'm not really sure if this has any difference between high and low, but I am going to go to low power. Now it looks like the driver's the same, so the power output... Oh, actually I'm still on high power, ain't I? Okay. Oh, I see what I did wrong. Then save it, then exit. Okay, so now we're on low power. And it looks like it's probably about the same thing going to it as far as low power. Probably just changes the a little on the outside of the... Let me just do something here. Just doing a couple of things here. I just want to check something. Okay, we still have voltage there. I was just trying to see if the voltage dropped when I transmitted. It doesn't seem to, so I don't think it's really dragging it down much. Change my coupling here. Turn this off. Okay, so I do want to make sure that what I'm seeing here when I transmit is actually the signal it's supposed to be. So I'm hoping I can get enough signal here, and I'll turn that down just a little bit more. Maybe have a chance to okay, so I'm going to go back to transmit. It's actually a fairly clean signal. Of course, I wouldn't be able to see that modulating. But let's see if we can measure the... So right here, we're going to look at the frequency right here and see if it gets close to 146 megahertz. Yeah, hovering right around that. Okay. I'm not sure this is going to work. I'm using 150 megahertz. Yeah, let's see. That's as far as that's going to go. I was just checking to see if I could get anything on 446. I might actually have to do this more with the spectrum analyzer, just with maybe the antenna over the radio or something. I might be able to check, make sure there's output on 446. Just reading off the driver. You doing anything here? Oh, yeah, I actually get, oh, see, look at the frequency there, right around 220. So it's actually, it's transmitting on 220. But like I said, it's 150 megahertz oscilloscope. That's pushing things right there. And then back to 146. So I'm going to say the driver is working, and if anything, right now I'm going to say that this is probably bad. It actually has a little bit of heat to it right now. So I think it's trying. It's just not. It's just not putting out. Let's try something else here real quick. There's like pretty much nothing coming out of the, oh, just, if I turn the sensitivity just way down, you know, I can finally start getting something coming out of the drain as far as a signal. And I mean, it's, yeah, kind of close to frequency. You know, there's a lot more going in than there is coming out. So there's out. There's what's coming in. Get that back on scale. Just give you guys a little comparison here. So here's the signal going in. Right there. And that's what's coming out. Okay, so there's nothing. That's not me touching it. Okay, that's what's coming out. That's what's going in. So I'm thinking that MOSFET is done. It's probably cooked. There's just not really anything going through it. So I'm guessing that's what's going to need to be changed. And I mean, it's warmer than the body. Let me put it that way. But if it were really trying to do anything, it would be pretty darn hot. I mean, the resistors around it are slightly warmer than it is. I think it's dead. So let's, I guess the next step is to try and find that. Maybe DigiKey or Mauser might be able to, might have that. But I got to figure out how to get it out of there, and then I got to figure out how to get it back in there. It's going to be pretty interesting, I think, to do that. Just because I don't know if y'all are going to be able to see this real well. I guess it'd probably help if I got the inset out of the way. As you can see, there's not like solder. It's just kind of sitting on the pads, and I'm guessing the solder is just a thin film underneath it. So I got to figure out how to get that out of there. And I mean, there's my finger. That gives you a little idea of kind of what size it is. Anything else I can say, you know. So here's your regular old screwdriver. I do have the power off, so before I'm sticking this in there, I mean, there's just the end of a regular screwdriver. So it's, you know, 1/4 inch across, maybe a little more. 5/16. 3/8 at best. I don't really want to just use hot air, because there's a, looks like a, let's see, probably a resistor right there. There's a coil right here. I don't want to heat that up too much, because that's like got a varnish on the the coil. I don't want it to short. So yeah, you know, this might be a chip quick application right here. If you're not familiar with that, it's basically like extremely low temperature solder, and it stays liquidy a lot longer, and it'll mix with solder. So I might be able to get in there and very carefully heat the gate, put some in there quickly, come over to the drain, put some in there, and in the source, maybe I can get it to flow up underneath there. And I should just be able to lift that off of there, and then I'll just have to clean it up with some solder wick or the vacuum gun or something. But basically, you put the chip quick on there. That's the brand name of it, I think. And when you flow it in there, it mixes with the solder, but it's got such a low melting point that it stays liquidy longer, and it keeps the solder that is there, since now it's mixed with it, it's liquid, and then you can basically just lift it right off. And then you just clean it up. It's pretty easy to clean up. I think that might be the best way to do that, if I can get in there and do that. Might unsolder the fan just to get this wire out of the way. I don't know, might not have to. But I'm not going to remove this until I can find a new MOSFET. There's no sense in taking that out until I know I got a replacement coming for it. So we'll probably put the radio back together. I've already got the part number. I just got to find out how much it costs. I'm going to guess it's, I don't know, 10-15 bucks. It might be small, but that doesn't mean it's, you know, just a 50-cent part. I bet it's probably 10 or 15 bucks, being a power RF amplifier as well. And we'll revisit this radio and see if we get one of these. We'll put one of these in there, and hopefully we're going to be back in business. Still don't know if the fan's supposed to come on just when it's warm, or if it's just supposed to come on anytime you transmit. I'm going to guess, since it didn't come on the entire time I've been kind of testing things, it's probably got there's probably a thermal sensor underneath here. If I took this board out, and I might have to take the board out anyhow, that shouldn't be too bad. Looks like a ribbon cable right here, and maybe a couple of wires going to the faceplate that would have to come off. Some screws, and it's pretty tight in there, but unsolder the antenna connector, it looks like, and probably lift that board right out of there. So we'll revisit that, but I gotta see if I can find that first. So that's pretty much what I got on this video, just kind of seeing what's going on with here, but I'm pretty sure that's the problem. It does receive, just doesn't transmit. See if we can find that, see if we can fix it. Thanks for stopping by the radio room. Hopefully in a very soon upcoming video, we'll be fixing this UV-25x4 by BTECH. And we'll give it back to the customer, and hopefully he's happy with his radio a little while longer. Like I said, I'm not really thinking they really spec that out real well if they're trying to drive it with to put 20 watts out. And you know, that could be a deal if let's see here, if this had a little lower drain voltage, you might be able, I mean, it would lower the power down, and it might get it closer to the 16 watts that's rated for. I believe the data sheet I was looking at listed it as a 12.5 volt, and we're running 13.8 into it, and that's what's on the drain there. So it might be they're just pushing the voltage a little bit on that side to get that power up to 20-25 watts. I'm not really sure, but that does match that data sheet. In fact, I found one, they had a picture of one that was for sale that you can't buy from that site. I actually found an image of one. It actually had the exact same number with the number I found. So I think this is more kind of BTECH supplier number, whereas the manufacturer actually has a different number. So, like I said, thanks for stopping by the radio room. See if we can get this guy working again in the near future in an upcoming video. Bye for now.